All right, let's talk about one of the unsung heroes of our digital lives, network quality of service, or QoS for short. Today, we're going to demystify how the internet manages to keep everything moving, especially when the network gets totally clogged up.
You know the feeling, right? We've all been there. You're in a super important video meeting, or maybe you're seconds away from winning an online game, and then, boom, everything just freezes. The video gets all glitchy, the audio cuts out. It's maddening. And believe me, there's a very real reason why it happens. What's happening is you're literally stuck in a digital traffic jam. It's like a highway with no carpool lane. Your critical video call is stuck in the slow lane right behind someone's massive file download, and the network treats them both exactly the same. So when things get congested, everything just grinds to a halt. So, how in the world do we fix this digital gridlock? Well, this is where quality of service swoops in to save the day. The best way to think about QoS is as the internet's traffic cop. Its whole job is to direct the flow of data and make sure the important stuff gets an open lane, especially when traffic gets heavy.
Now, here's the key thing to remember. QoS doesn't magically create more bandwidth. It's not about building a bigger highway. It's all about intelligently managing the highway you already have. It's a whole collection of tools that work together to prioritize your traffic, making sure that real-time things like video calls are safe from all the less urgent data.
So, the QoS toolkit really works its magic in 3 main steps, and we're going to walk through each one. First, it has to sort through all the traffic. Then, it manages the lines, or queues. And finally, it enforces the speed limits. This 3-step process is how we get from chaos to order.
Okay, let's get into step 1. Before the network can give anything priority treatment, it has to know what it's dealing with. And that's exactly what classification and marking is all about. It's the process of identifying every single data packet and slapping a tag on.
This is probably the perfect analogy. You know, when you check in for a flight, you can get a priority tag on your bag. That little tag tells every single airline worker to handle it with care and get it on the plane first. Well, QoS does the same thing for your data, marking your video or voice packets so every router along the way knows, hey, this is a VIP, give it a clear path. So how does this tagging actually work under the hood? Well, network devices have a few tricks up their sleeve. They can look at simple stuff like an IP address and port number, or use more advanced techniques like NBAR to figure out exactly what application you're using. Once it's identified, that data gets marked with a special priority value, like a DSCP code that acts as its VIP pass across the network. All right, so our traffic is sorted, it's all tagged with its priority level. Now what? The next step is all about organization. This is where queuing comes in. We're going to manage the lines and make sure our VIP data gets its own express lane to the front. On one hand, you've got the most basic, old-school method, first in, first out, or FIFO. It's exactly what it sounds like. One big, single-file line where everybody waits their turn. A huge data burst can hold up the line for everyone. But on the other hand, we've got a way smarter system, like low-latency queuing, or LLQ. This creates multiple, separate lines, including a super important express lane that is strictly reserved for sensitive stuff like voice and video. It always goes first, but without totally ignoring all the other traffic. And this chart just says it all, doesn't it? Look at the difference. With a simple FIFO queue, the delay for your important stuff can go through the roof when the network gets busy. But with an intelligent queue like LLQ, that delay is slashed dramatically. That's what gives you that smooth, uninterrupted experience. And that brings us to the final piece of the puzzle, enforcement. QoS needs a way to actually control the speed of traffic so that one greedy application can't just hog all the bandwidth. And it does this with 2 key tools, policing and shaping. So what's the difference between these two? Well, think of policing as a super strict bouncer at a club. If you try to send data faster than the speed limit, it just drops the extra packets. No questions asked. It's a hard, unforgiving limit. Shaping, though, is more like a chill event organizer. Instead of just dropping the extra data, it holds onto it in a buffer and sends it out a tiny bit later, smoothing out those traffic bursts into a nice, steady stream. And here is what policing looks like in the wild. You see those big spikes in traffic? The second a peak goes over that configured speed limit, bam, it gets clipped right off. Those are dropped packets. It's a very direct, very aggressive way to enforce the speed limit. Now compare that to shaping. It's a totally different story, right? Instead of just chopping the peaks off, it rounds them out. Those bursts are held for a moment and then sent out over time, creating a much more consistent, predictable flow of data.
It saves the packets, but at the cost of a tiny bit of delay.
And just to show you this isn't just some abstract theory, here's a little snippet of what a network engineer would actually type into a Cisco router. This command is telling the device to police traffic at 1 gigabit per second, and that the exceed action is to drop it. This is literally how these rules get built into the internet.
So, let's just take a step back and see how all three of these tools, the sorting, the queuing, and the rate limiting, all work together beautifully to prevent those digital traffic jams we all hate.
So really, let's boil it all down. At its heart, QoS is the traffic cop for your data. It figures out what's important and gives it a VIP tag. Then, it creates an express lane so that VIP traffic can skip the line. And finally, it acts as a rate limiter to make sure no one application can cause a pileup. These three steps are what turn a chaotic digital free-for-all into a smoothly flowing system.
And all this leaves us with a really interesting question for the future. As our online world gets way more complex with AI, virtual reality, the metaverse, all of them are going to be fighting for a slice of that bandwidth. The question won't just be how we prioritize data, but what we as a society decide is most important. Thanks for tuning in.